I'm going to show you that how to print means how to find the which term is present, which element is present at the particular position in the Fibonacci series. So here I go. First of all, I'm going to write hashtag include studio.h. Then I'm going to write int main. Then I'm going to take input from the user. I'm going to create a variable int n, printf, enter n. Then I'm going to write scanf as I'm going to take the input, like the user want to find which, at what position they want to find which number is present. So scanf %d, and I'm going to use ampersand n. So after taking input from the user, what I'm going to do that I'm going to call the function, and I'm going to store it into a variable int x equals to fibo, and I'm going to pass the value of n over here. And now let us create the function fibo n, which we are calling it over here. So I'm going to create it fibo n, and not n, suppose we stored it in the variable int x. And the most important thing, you have to think that you have to write int over here. You have to write int over here, because either you can return void or you can return int. So you have to write int over here, int fibo, int x, and then you are going to create that what logic you are going to apply over here. So I'm going to I'm going to write return, as I'm going to apply which method, recursion. I'm going to apply over here recursion, and the fibo n minus 1 plus fibo n minus 2. And most importantly, here we have passed n, but here it is stored in the variable x. So here I have to write in the container x, with the name x it is stored. So I have to write here x because of this variable scope, and here I have to write x minus 2. So you might be thinking that why is this so that we are writing this. So have you ever seen the Fibonacci series? It is like 1 1 and the sum of the previous and after previous one. 2 plus 1, it gives 3. 3 plus 2, the next is 5. 5 plus 3, it gives 8. In this way the Fibonacci series goes on. It is the sum of the previous and the previous number which is present over. So here it is the sum of the Fibonacci series, and I am returning it as x minus 1 plus x minus 2. Means suppose I have to find the user enter the third position. So fibo 3 minus 1 2 plus fibo 3 minus 2 1. So we know that we have to apply some base case, otherwise what is going to happen, that the recursion is going to keep on calling itself continuously. In order to avoid that, what we have to do over here, that we have to declare a base case, that if this condition is striked over here, then you have to apply the particular value. So I'm going to write if I am clearing that x is equals to 1, or I'm using the or operator. Till now you would have been aware of different kinds of operator, or operator, and operator, and all the arithmetic operators, relational operators. So here I'm going to put if x equals to 1 or x equals to 2. If it is this the case, then you have to return the value, return 1, because we are fixing the condition over here by seeing this, that if the x was equals to 1, means at the first position, and at the second position the number remains 1, and in the next position it is the sum of the previous ones. So return fibo x minus 1 plus fibo x minus 2. Okay, and then I'm going to printf Sometimes, wait a second, let me first complete it. Printf percentage d comma x, so that this Fibonacci number gets printed over here. And let me tell you one most important thing. In the recursion, it is very important for you to dry run the things. If I'm going to say that you are going to understand it completely, you will definitely understand it when you are going to once dry run the things by yourself. You take the input, like you take 3. So then you are going to apply that I have to find at the third position which element is present. So you are going to put Fibo 3 minus 1, it gives 2, plus 3 minus 2, it gives 1. So at we have already put the base condition. If it's x equals to 2 or x equals to 1, it is directly going to return 1. And once the return is striked, it means that it is going to reach at the position from where it is being called. And then it is going to reach its position from where this function is called. This function is called from here, then it reaches there, and then the next line is printed. So it's very important sometimes to dry run the things. Sometimes, so what, in coding you have to dry run the things, especially when you are learning the things through recursion tree. You make recursion tree, then the things will become clear. If I'm taking the input from the user, what you do, you only take the input, like at the 5th position you have to check, then you do Fibo x minus 1 plus means Fibo 4th position plus Fibo 3rd position. Fibo 4th position will be further again. This function is calling itself. The recursion is basically this only, the function calling itself. So again at the 3rd position, what you are going to find, that when it is going to come for the 5th one, Fibo 4th and Fibo 3rd, Fibo 4th is then again going to be broken into Fibo 3rd plus Fibo 2nd, and the Fibo 2nd value, which is going to give 1, as the x equals to 2, then it is definitely going to give 1. And in the same manner, and then you add up the things, and once the return is striked, the things are going to return itself. So in this I think this was a sufficient explanation. Let's run this code. Enter n. Suppose I entered for 5th, the way I was telling you. For the 5th position is 5th only, 1st, 2nd, 3rd, 4th, 5th. Suppose I run the code again. Again I'm going to run it, and this time I'm going to find for the 6th position. The 6th position for the Fibonacci series is the 8th. So this is the case for the Fibonacci. The recursion is basically the calling itself, and it's the foundation for learning the programming. So this was all for today. Thank you, and dry run the things, think the logic, and keep learning, keep smiling.